we're going to look at two fundamental trigonometric limits and walk through some examples. The first limit that we'll look at is the fundamental sine limit. This is the most important trigonometric limit, and it provides the foundation for finding the derivative of the sine function. This fundamental limit is the limit of sine theta divided by theta as theta approaches 0 and is equal to 1. I think this limit can be best understood if we look at the graph of sine theta and theta. On the right, I have graphed sine theta and theta. As theta gets close to 0, that's in this region and in this region, you can see that the two graphs are virtually the same. That means that they're about the same number, and when we divide two numbers that are the same, we are going to get the value of 1. So this limit is equal to 1. Let's now walk through some examples where we are going to find the given limit. Here's our first example. We want to find the limit of sine of 5x divided by 3x as x approaches 0. The first thing that you always want to do whenever you're given a limit is substitute in the value. So let's go ahead and let's do that. If we let x be 0, we get sine of 0 all divided by 0. Sine of 0 is 0, so this limit is 0 over 0, which is called an indeterminate form. When you're solving any limit that has a sign in it, you want to utilize the fact that the limit of sine theta over theta as theta goes to 0 is equal to 1. If we look at our limit, I want you to focus on the 5x right here. Think of the 5x as theta. So we need to have a 5x in the denominator. So we can say that this is the limit as x goes to 0 of sine 5x all divided by 3x, and we're going to multiply by 5 over 5 because we can't change the problem and just divide by 5. Now what we're going to do is we're going to shift this 3 and this 5. And we're just going to rewrite this as the limit as x goes to 0 of sine 5x all divided by 5x times 5 over 3. We now know that this limit is equal to 1 because it's just like sine theta over theta. So we have 1 times 5 over 3, so we get an answer of 5 over 3. And that's what our limit is equal to. Let's now work through our second example. This one's a little bit harder than the first one. This is the limit of tangent 6x divided by sine 2x as x approaches 0. Just like we did for our first one, we are going to start by substituting in that x is equal to 0. So this is tangent of 0, all divided by sine of 0. Tangent of 0 is 0, sine of 0 is 0, so we again have the indeterminate form 0 divided by 0. Since we don't have a formula for a limit with tangent, I think the best way to solve this problem is to let tangent of 6x be sine 6x over cosine 6x. So we can write this as the limit as x goes to 0, sine of 6x all divided by cosine 6x, and then all of that is divided by sine of 2x. Now you can see that we have a sine 6x on top and a sine 2x in the denominator. To evaluate these limits, we need to divide sine 6x by 6x, and we need to divide sine 2x by 2x. So what we're going to do in our numerator is we're going to multiply this by 6x divided by 6x, and then in the denominator, we're going to multiply by 2x over 2x. Let's see what this gives us. This gives us the limit as x goes to 0, sine 6x over 6x times 6x all divided by cosine 6x. We're just changing around terms. And then in our denominator, we have a sine 2x divided by 2x times 2x. This limit is going to go to 1, and this limit is going to go to 1. And then notice that our x's cancel out. So what we're left with is the limit as x goes to 0 of 1 times 6 divided by cosine 6x, all divided by 1 times just 2. Cosine of 0 is equal to 1, so this is just 6 over 2, which is equal to 3. And 3 is the value of our limit. Let's now go over the fundamental cosine limit. This limit is also used for finding the derivative of the sine function. This fundamental limit is the limit of 1 minus cosine theta divided by theta as theta approaches 0, and the limit is equal to 0. I think this one is a little bit harder to memorize than the sine one, so you may have to spend some time memorizing it. This limit can be derived algebraically by multiplying by the conjugate of the numerator and then using the fundamental sine limit. I am not going to go through that in this video, but if you want to do it, I'm sure you can do it if you follow these directions. What we're going to do now is walk through an example where we find a given limit. The limit that we are going to evaluate is the limit of 1 minus cosine x divided by sine x as x goes to 0. Let's begin evaluating this limit by just substituting in that x is equal to 0. So we have 1 minus cosine of 0 all divided by sine of 0. Cosine of 0 is 1, so we have 1 minus 1 over 0, which gives us the indeterminate form 0 divided by 0. To evaluate this limit, we have to use two things. The first limit that we can use is the limit as x goes to 0, sine x all over x is equal to 1. And then the one that we just saw above, the limit as x goes to 0 of 1 minus cosine x, all divided by x is equal to 0. When you look at the limit that we've been given, 1 minus cosine x over sine x, you can see that it's similar to these two limits that I just wrote down, but there's no x there. So I think the best thing that we can do to evaluate this limit is divide both the numerator and the denominator by x. Let's go ahead and let's go down here. I'll draw a little arrow here, and let's do that. So this is the limit as x goes to 0 of 1 minus cosine x all divided by x, all divided by sine x divided by x. We can do this algebraically because we're dividing both the numerator and the denominator by x. So it's just like multiplying by 1. You can see then that our top limit, 1 minus cosine x over x, is going to go to 0. So let's just put an arrow here. That goes to 0. And then our limit on the bottom is going to go to 1. So we'll say that goes to 1. So our answer is 0 over 1, which is 0. And that's what our limit equals.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.